show you this before I forget or don't get a chance. I said I was gonna do it yesterday, and then I basically was I was asked a lot of questions during R&R, so I just forgot all about it. I put a section for getting ready for the AP test. And I put quite a few things in there. I don't know if any of your other AP teachers showed you this yet, but I believe Miss Salmon, the AP person at our school, put this website together. It basically is just all information about the AP tests. So if you have more than one, it's got the schedule over here, which you probably already know for your class. Information which you might already know or might not, but like our test is at 8 a.m. I guess I don't know if I've specifically gone over that with you, or if maybe you didn't even know. Our test is at 8 a.m., so you need to be here about 7:30, 7:40 before school. So they give 4 hours for each of the AP tests. And so the morning session goes from 8 to noon, and then the afternoon session goes from noon to 4. So if you don't drive, you want to make sure to somehow figure that out and arrange that. Ours will be in the gym. And then she just put together all sorts of stuff. So if you guys want to look at all this, go for it. It's a lot of information. So they release the FRQ questions every single year, but not multiple choice for whatever reason. My guess is they just don't want to run out of questions to use, so they just try not to release the multiple choice a lot. But the free response they can rotate and use a lot of. So I've got questions that go from 1998 all the way to last year. So if you really have a lot of time, you are more than welcome to look at what types of FRQ questions are given each year. So, like, there is some general guidelines they follow, but they don't tell us. They generally will give one volume or area question as an FRQ each year. So that's traditionally one of the 5 you can count on. There is always one related rate, for better or for worse. And then the other 4 are usually just made up of all the rest of the topics from Calc. I think they try to highlight the area and volume and the related rates because they're usually considered probably the harder topics of derivatives and integrals. And then they just kind of give other ones. Like some years they've had you draw a slope field. Other years they'll have you do a limit. I mean, like, the FRQs don't have to be difficult, but they're kind of all over the place. And you don't know what there's going to be. So if you would like to look at past ones, like if you look at 2024, you're not guaranteed, but you're probably going to have different types of questions that were on 2024 because they usually don't do them 2 years in a row. I would say it's roughly like a 4 or 5 year cycle where they try to rotate things. We're going to do some FRQ together during the review and do some various topics, but anybody who's trying to prep and get ready on their own, I wanted to put stuff here. Those who are going to use the TI-84, these were things that I found online that people had made up for their students. I believe the one on the bottom here that says TI-84 for calculus, that was the main one that if I remember correctly, that kind of tried to guide you on the things you need to know to be able to do on the AP test. Almost none of you have the actual textbook, but in the textbook, each chapter or unit had AP style questions at the end of it. And so these are the questions from each of the units and the answers. And then we've done circuit worksheets throughout the year. I've collected a lot of different circuits from various topics. Oh, actually, I have more than I could put in there. I forgot about the other folder. So I've got a lot of things you can practice and try. But not just this. I know I opened up the Blue Book app the other day. No, that was a little while ago now, wasn't it? Oh, that's right. I don't want to do that. I forgot it can't save your username and password. So. It usually takes me like 5 tries to get in. If you guys sign into Blue Book on your Chromebook, do you guys know how to get to that? It's the same as ACT or MCA. You have to log out and log in through the other method. Blue Book has a full, complete practice test. And so that would have the exact same number of questions that the real test is going to have. So it'll have 45 multiple choice. I believe it has 30 without calculator, 15 with calculator, and you are given approximately 90 minutes, I think it is, for the 2 sections. And then there are 6 FRQs. It is usually 4 FRQs, excuse me, the first 2 FRQs are with calculator, the last 4 are without. You will always do multiple choice without calculator first, so that they can have everybody's calculator away. Then you will do multiple choice with calculator, then the free response with calculator, so that the calculator's out for both of those portions in a row. And then they have you put your calculator away, and then they give you the last 4 FRQs. You are allowed to go back and edit the 2 FRQs just without a calculator. And then that approximately is 3.5 hours. I mean, it pretty much feels like taking an ACT, except it is solid calc rather than variety of topics. There is a break in the middle. We'll have some mince snacks. I can even bring my magic stamps. Whatever we need, I'll be out there that morning. Usually you guys are completely dead tired, coming in an hour early before school, and we'll try to wake you up. Okay. I wanted to make sure you guys knew all that stuff was there, so that if you're trying to start studying now, you have some information. The Barron's books, the Princeton Reviews, the Kaplan, I think it is, those are all great, and they will work well too. So whatever you have, I've got flashcards you can check out if you want to do flashcards for Calc. Everybody studies differently. Okay, let's do the last section, which, to be honest, I think is going to go pretty well, since yesterday's seemed to go well. And I'm going to go straight to the second page of notes. And we are going to try this question together right away. Will, ready to start? Nice. Okay, I was hoping you could come up and draw the equations it says that create the shape. Square root of x is the most difficult part of that. And I can help you, guide you if you need help guiding drawing that. That dotted line up above is y equals 4. So in terms of spacing, there's no tick marks for some reason, but that's 4.
So for, you want me to write the red x? Isn't that like?
Yeah, it's sideways parabola.
Yeah,
Yep, perfect. And that's pretty much exactly correct, because it's going to be at a height of 2. Okay, x equals, well, whatever it says.
Oh, x equals 4.
X equals 4, y equals 0.
Here, probably.
Oh, you mean trying to judge?
Yeah, because there's no way to tell.
Yeah, it's going to make a square with the dotted line.
Okay.
No, you don't make that one dotted.
I'd make that one solid.
Yep. The dotted part of the line is to represent that that's what you're rotating around.
And y equals 0, that's kind of already there.
Perfect. So the only reason they include y equals 0 is because those 3 lines make an enclosed area. So if you could take another color and shade inside that section.
This another color.
Sure, I don't care what. Your choice. Did you really pick like dark blue that's basically black? I realize I said your choice, but that's a strange choice. Okay, that's a good one. We'll make everybody happy.
Okay, now what?
Color in the shape that we are gonna be rotating.
Is it this one?
Yeah, so I wanna make sure everybody knows what the enclosed shape is. The equations they give you will always create an enclosed area. That is perfect. That was a great job. Done.
Cool.
Who's next? Wow, that is a shock. Okay, Thomas, what I was hoping you could do, and try to pick the red marker. One, signify where you're rotating by doing the little twirly. And then draw the radius or radii. Because that's where it says method, means you have to know which method you're using by the picture that's being drawn. And I could guide you if you want some guidance, like if you're not sure on the radius. So I feel like the revolving twirly part, you know. Nope, yep, yep, perfect,
That way.
yep,
Revolving around this is like R
excellent,
here and then
perfect.
maybe two R's.
So the little r is always going to be started at the axis of revolution, and then you will draw until you hit the object. Big R starts at the axis of revolution and is drawn until you hit the end of the object. So this one feels weird because the radii are like above it. But that's okay because we're rotating above it. Can anybody picture what this looks like when it's rotated? Here's the best description I have. Yeah, a little bit. The best description I have is I'm pretty sure a majority of you have been to the Science Museum. Probably. Well, okay. At the Science Museum, and I'm sure other places, they have this one little, it looks like an inverted horn. You put a penny on it, and the penny starts circling around the inside, and then as it gets closer towards the inside, it spins like crazy fast. That's exactly what this shape would look like sideways. Because when you rotate it, the outside would be a solid cylinder, so that'd be like the outside of that thing. And then the inside would be a horn shape but hollow. And so the only thing you would see is the little tube down the middle, and then it would gradually come out. Funnel-ish, yes. Wait, so do you guys know them? They still have that at the Science Museum, I'm assuming, right?
Probably.
I haven't been there for a while, because they really haven't changed much, so I just stopped going. Do I need to look up what you get? Okay, we'll do it later when we have time. Theoretically, you don't have to even know what this looks like, as long as you can draw the correct info. Thomas, number or person, I was hoping this person could write the information for the radii. Basically, those top two lines, write how long the line is.
19.
Somewhere over there. I take it Tyler?
Yeah.
Okay. Did you call him Tyler yesterday too?
No, I didn't. That was not.
I've been called in every day, so.
Nice, all right. That's what you get for stealing all my candy and gum. Okay, what I was hoping you could do is come up here and write down the length of little r and big R, because that's what we're gonna have to put into the equation to integrate.
Do you want me to start writing it down? Do you want me to start writing it
Nope.
down? Okay.
See the line that says outer radius, inner radius? Nope. Nope. Yep. Nope.
How do you write this in your writing? Oh, right here.
Yes.
Mhm.
Okay, so outer radius is gonna be big R, inner is little r, not that that really matters that much.
Mhm.
Okay, so do you remember how to find the length of the line? What did we do yesterday?
Forgot.
Okay, top minus bottom.
Yeah, I remember that, but I don't
Oh, well, you said you forgot.
Well, I don't know, like, which one's like.
Okay.
Which one represents each.
Put it up, put your marker on the top of little r. Okay, what's that height?
It's from,
Nope.
oh, the height,
What is the height of the top of little r?
4?
4, and it's not gonna change because it's always gonna be at a height of 4. Okay, so little r was inner radius. Write down 4. No, there's a line to write it. Yeah. 4 minus. Now we're going to subtract the bottom.
Okay, then square root of x.
Looks like you've got that part down. Correct. The bottom height will always change, but it will change according to the equation.
Square x, minus, no, we don't.
Okay, so the outer radius is going to be, top is at a height of
4.
4. Bottom is a height of,
0.
perfect. The outer radius is actually always going to be 4. Yeah, it's actually just a single number. It's not variable. Okay, good, you're done. That's usually the most difficult part for most students, is writing the information for R. Okay, Tyler, number, not a person, not Cullen or Max.
1.
You are so difficult to give directions to. Yeah, I only gave you one stipulation,
8.
not Cullen or Max.
8.
Okay. Still a Max, I mean, I didn't really specify, I guess. I got you, Max.
And 7.
You came up yesterday too.
Meant
I don't want the same people coming up all the time,
7.
unless your name is Adam.
7.
7.
7. I meant to say that first.
Yeah, all right, good call. Adam, come save this group. Okay, now the next thing we would do, it does say method, I don't really care if you fill that out. This is gonna be washer method because we've got 2 radii. If you have 1 radius, it's disk method. Okay, now we need to fill out the integral. Basically, write down what you would type in a calculator to get the answer. And I can help you set it up if that's what you're wanting.
Will the intercepts be in notation of y because we're rotating around like y equals 4?
No. It's because the radii we drew are vertical, we have to input information into heights. And so those are, well, they're y answers, but the equation would be x's.
Okay.
It's the same as when you rotate around the x-axis.
Okay.
If it makes it easier, whenever you're drawing vertical information, x's go in the equations. Whenever you draw horizontal, y's go in the equations. Okay, so you are, go ahead, sorry. 4 squared minus. Okay. What are you looking at me for?
I don't know.
Are you asking me something?
I don't know if it's right.
Oh, ask them. Oh,
What?
nothing, I accidentally clicked the mouse. Is that right? He wants to know if that's right. Lainey thinks maybe one way or the other.
Do you need to add pi?
Perfect. You did the r squared but forgot the pi. Yep, it is super easy to forget the pi. Obviously it'll be the wrong answer. The annoying thing on multiple choice, I can pretty much guarantee you one of the multiple choice answers would be the correct info without the pi. But hopefully when you see pi written in another choice, you would remember it. But that is absolutely the easiest part to forget. So it's pi r squared minus pi r squared. And it looked to me like, Adam, you were just doing r squared minus r squared right away. And I'm guessing you intended to put that and just forgot about it. How are we doing on this one? Did you guys feel like you could have filled this one out on your own? Okay. Since that didn't take us long, why don't you guys see if you can draw this one and write out the integral that would get the correct answer? These take so long that it's very difficult for us to actually integrate them to to get the answer. So. If this were a multiple choice question, it's possible they would write the R's as simplified. So I would kind of expect big R to be written as 5 minus x squared, little r to just be written as 1. Actually, they'd probably even just square the 1. But if you're doing this on free response, the way they usually have you do it is just write out the integral that finds the answer, but then not actually do it. And if that's the case, you are welcome to write it as extended and unsimplified as you want. But otherwise, I've got the info up there. This one, we had to calculate where they intersected to be able to figure out where the integral started and stopped. So -2 to 2. That's what I wrote in green. And then little r started at the dotted line and went up to the figure. Big R started at the dotted line and went up to the end of the figure. Anything up there that's maybe somebody isn't sure why I wrote certain details, or maybe I wrote something wrong? That happens plenty frequently. I'll pretend like I do it on purpose, to double check you guys.
For the outer radius, why did you do minus -1? You're supposed to add it.
Say it again?
Isn't the big R like the entire?
You mean, why didn't I write 4 minus x squared plus 1?
Yeah.
Yeah, I did. I mean, it doesn't matter if you write minus -1. I simplified it down below because I added 1 to the 4. Yeah, in the outer radius info up top, I basically wanted to leave it unsimplified to show you where I got it from. I had top minus bottom. It doesn't matter whether it's rotating below or above. You're finding the length of the line, so it's always the top minus bottom or right minus left, which our first two examples were horizontal rotating. Our next two examples are vertical. So these are top minus bottom just because they're vertical. Next one is gonna be right minus left. Should I move on, or are you guys catching up and need to ask where I am? I don't know. I know how to do this. I'm trying to help you guys learn how to do it, but you're giving me zero indication. I should move on? All right. Somebody finally said something. I want to go down to the last example. Adam, is there somebody you want to call on or number? No. All right. Here's the bell. You get to draw the info for us, and I will give you some guidance if you want. So we've got y equals 2 root x, y equals x, and then the dotted line is already drawn.
There's our y equals x,
Okay, that's a good one to start with.
and then the y equals 2x, or 2 times root x would be like that.
It would.
Actually, do we need the arrows on it? And then,
Wait, say it again?
that's it, right?
You said something about arrows.
Do I need the arrow or no?
So technically, all we want is the enclosed area that those equations make.
That part.
Yes.
Okay,
Done?
I think so.
Okay, perfect. Are we calling it anybody specific? Addie? Sounds good. I can tell you what to do next, otherwise I can just leave it up to you as to what we should do next.
Should I draw the R's?
Sure. There's a variety of things we could do. Right? Okay, good, good, good. That's the twirly line, yep. Little r is directly from the dotted line to the object. Big R is directly from the dotted line to the outside of the object. Perfect.
Can be done. Can be done.
Absolutely. Just so you guys know, you don't actually have to come up. Like if you're really worried you're gonna get it wrong and it's like devastating to you, I don't really care if you go up or not. I just call you up. I'm just letting you guys know, you're all in the same boat. Like every single person in here pretty much thinks that they're not really sure if they're right or not. So don't feel like you're alone, you know. That's the whole point of the class. If you guys already knew how to do this, you wouldn't be here. Who's gonna go? Yeah, you can't call in Isabella.
I know. Dylan.
Oh, that's Wyatt. No, I was kidding, I was kidding. You ready?
Yeah.
What should we do next?
Um,
It's a variety of things we could do.
define what's the outer and inner radius.
Okay, so we can write down the lengths of them? Sure. Now, because it's right minus left, we don't care about the height of the line. I mean, we care, but we're not gonna be writing it down. And so I want to point out that the equations we were given were for finding the height of a line. So we have to rewrite them so that it finds us the x value instead. So basically rearrange them so they say x equals. I mean, x equals y, right, like that's like the easiest one. I don't know what that says.
+2.
Where'd we get to? Okay? If you rearrange y equals 2 root x so that it says x equals, there you go.
Oh, yeah.
Perfect. Yep. Ooh, so close. Oh, actually, no, the way you wrote it's fine. I thought you were gonna actually square it, but if you write it as 1/2 y squared, that's totally fine too. Perfect. Now, you can sit down if you want. For people trying to figure out what's going on up there, do you guys want me to write down some details on the graph for you at all? Would that be helpful? Sure. I'm pretty sure Dylan did most of it in his head. So that curved line was y equals 2 root x. And if you rearrange y equals 2 root x so that it says x equals, you would get 1/2 x squared or 1/4 x squared. Doesn't really matter how you choose to write it. So this curved line is x, I wrote x, didn't I? This curved line is x equals 1/4 y squared. And then the straight line that was y equals x, when you rearrange it for x equals, still says x equals y. So big R would be the green info minus -2, because this is x equals -2. So I would take y minus -2 for big R. For little r, 1/4 y squared minus -2. You just want to make sure that when you're writing down, these all have the same layout. X equals, x equals, x equals. Like they should all kind of match up, line up. Now we gotta actually figure out. Is that Will or Monty? Lena, you're close. And you're leaving early, so let's have you go up. What I was hoping you could do is figure out the numbers that are gonna go on the integral. I don't know, where did that come from? Okay. On the AP test, don't consider it a given. Like actually, when you set them equal to each other, I don't know if you just did it in your head, write that out. But you are correct. So set the 1/4 y squared equal to y. Where'd it come from?
Equation?
No, it did not. Did you just throw in numbers knowing that was the correct answers?
Yeah, pretty much.
Oh, you can't do that. I mean,
So
you can, you just won't get it right. How would you actually solve
set
that?
it equal to 0.
Okay, since it's quadratic, you have to make it equal to 0. And in this particular one, you can factor out a y from both. Yeah, and then set each one equal to 0 individually, which would give you 0 and 4. Yeah, that's perfect. That would be perfect and acceptable work. Okay, good. So these are the numbers that we need to put on the integral. The integral is going to go from a height of 0 to a height of 4. Okay, Lena, we need one last person to write us the integral. And then this integral would, oh, too much. What was that noise? Do you want me to put it back?
No, it's fine, I can just do it.
You could what?
I can just do it.
Okay, otherwise I just hit undo and it's back. Ready? Integral. So Lena just figured out the numbers that go in the integral. It's going to go from a height of 0 to a height of 4. We'll guide you. You look like you want some guidance. Okay. So integral 0 to 4. And then we're gonna do pi big R squared minus pi little r squared. Okay, now big R is outer radius. Yeah. If you are a person that finds it helpful to have like steps in a problem, you could absolutely set it up like this problem is set up, where you want to find the radius kind of as its own step, and then put in that info afterwards. Oh, I got you. You put a bracket for the pi. Yep. Perfect. Done. I didn't realize after the fact, we didn't have any that were disk method. They were all washer method. Is the one above disk method? X squared 4. Nope. That's kind of odd. All 4 of these were washer method. How early are you going to leave for your game?
I'm excused for the whole period.
No, you're not. It says 2 o'clock.
But it says I'm excused for the whole period.
I have an eye appointment today too. I'm not going to ditch the entire hour just because I got to go to that.
You should.
What do you need?
No, not that.
You definitely are not fine.
I was just talking to her.
Were you trying to make fun of me while I was talking to her?
Oh, no, not about you.
Yeah, never, never.
Not about you.
It's okay, I can take it.
No, it was not about you, I promise.
Okay, should we do the top one? Do you guys feel okay with this? Oh, yes, do it.
Yeah.
All right, Cullen,
Yeah.
let's draw the picture, please. What? I'm allowed to call on whoever I want. Is that what you were mad about? What, is she sleeping? What? Did you stay up too late?
Yeah.
Oh, jeez. Pretty soon, you got the entire summer. And then you can plan your classes next year so that they're not at 8 in the morning. Actually, wait, don't you have that like right now? Don't you not come here until like noon? How are you tired?
I have class at 9 a.m.
Oh, all right. Do you want some, if you want some help, just say so too.
I mean,
I wasn't watching what you were doing, but,
Just as
y equals 4, that's perfect.
I
Yep.
draw the arrows.
Nope, no arrows. There's not gonna be arrows because we specifically, we only want the section that is enclosed by what they give us. Okay? Who are you calling up? Non-maxes.
18.
Broad, oh, there we go. I was gonna say broaden your horizon.
Yeah.
I don't know where 18 is.
It's not like the last 3 days again.
Cool, the AP test doesn't care when you're gone. And let's just pretend you're at college. They don't care when you're gone. The test is when the test is. And if we're gonna try to pretend like we did debate for 7 days straight and had no downtime to do homework. Mm-hmm.
Wait, what? Okay.
Okay, what I need you to do is to draw the little radius and the big radius. So now you probably semi-saw from the last 3 problems. The dotted line is what we're revolving around. The little radius is going to be drawn directly from the dotted line to the shape.
Okay. So like, doesn't matter like where I draw the.
It doesn't matter the height, no, is that what you meant?
Yeah.
Nope, not at all. Perfect, that is little r. Big R will be dotted line,
Yeah, so like the outside.
yep,
Right.
see, great. Didn't even matter, you're gone. Okay, good.
That it?
If you wanna keep going, you can, but,
No.
oh, okay.
Vincent.
Oh, I'm overriding this one. We need to choose people who never get called on,
Thorns.
unless their name is called. What did you call?
Thorns.
Okay, I have 4 minutes and then I have to leave. We need to call on somebody who can do the entire thing. So 2? Oh, I thought you were trying to say somebody. Tyler, I thought you were saying something to me. Vincent, are you serious? You're like trying to pass it out. I saved you, and you're trying to pass it out on other people. Okay, now this one theoretically isn't necessarily harder, but one thing needs to be done. Foster, what is the one thing that needs to be done to make this work?
You have to like separate the like negative root y and positive root y.
You meant it correct. You need to make this say x equals. Correct, you need to rearrange the equation. So you were correct when you said separate it. This equation needs to be solved for x because we're doing this horizontally and we need right and left info. So this is x equals plus and minus square root of x. Oh, why? Plus and minus square root of y. Are you trying to help him? Okay. So the outer radius is going to be the right info minus the left. The right info is 3, so x equals 3. The left info is x equals negative root y. This is positive root y. Okay. Inner radius, down here, right is 3, left is positive root y. And then our integral, we would have to set them equal to each other. No, we wouldn't. We are going from the bottom to the top. So this goes from 0 to 4 because we were told it was 4. So we're going to go from 0 to 4, y equals 0 to y equals 4. And then the equations, pi big R, which would be 3 plus root y squared, minus little r squared, pi little r squared, 3 minus root y. That generally is going to be the toughest part of some of these, is that you have to know which version of the equation you need. Okay, I'm done.